everybody, Mr. Covey here, and this is the second video for this learning check, and we're going to be talking about graphing exponential functions. Okay, so first thing to remember is the reason that these are exponential functions is because there's an x in the exponent. Okay, so it's always a good thing to remember as like a definition, kind of an idea, like what does exponential mean? It means there's an x in the exponent. Okay. We're going to graph these, and we're just going to state a couple of features of the graph, the domain range and the asymptote. Okay. First, I'll pull up a little Desmos thing here to show you guys something. Okay, so here's a graph of 2 to the x. It looks, we saw this in that very first Desmos we did. It looks like a rocket, you know, it goes, shoots up into the air. Okay, and that's what the graph of 2 to the x looks like. A graph of 3 to the x, well, it shoots up a little steeper, but very similar shape. 5 to the x, even steeper, but very, very similar shape. So based on those three, all exponentials kind of look like this. They go, now, that's not entirely true, because if you look at 1/2 to the x, it looks like this. Ooh, it's kind of sad. Instead of shooting off, it goes, whoa. 1/3 to the x, whoa, same kind of thing. Like, whoa. And that's because these two we describe as decay, exponential decay, while these three we describe as exponential growth. So what changes it from growth or decay? Well, if you look at these, it's all about that number, that base, and it's all about whether it's bigger than 1 or less than 1. If your base is less than 1, it ends up looking like this, and we call it decay. If your base is more than 1, it ends up looking like this, and we call it growth. Okay. The cool thing is, though, all of these graphs go through the same one point, which is 0, 1. Just really cool. So 0, 1 is a point on any exponential before we do transformations. Okay. So jumping back here. So we're going to do this through a transformations lens. So when we're trying to graph this, by first thinking about where it came from. So it's 3 to the x minus 2. That minus 2 is a transformation. So I'm going to start by just thinking about y equals 3 to the x. And I'm going to try and think about a couple of points on that original graph, and then I'm going to do the minus 2 transformation to it. Okay, so y equals 3 to the x. I'm just going to really think about 2 points on the graph. 0, 1, because that's on all exponentials before we do transformations. And then if I plug in an x value of 1, what's 3 to the first? Well, it's just 3. Those are 2 really easy points to figure out on this graph, and so they're 2 good ones to start with. Then I'm going to do the transformation. What does a minus 2 up there do? Well, it's kind of like a minus 2 on the inside, so that's going to move my graph right 2. And if I move it right 2 to get this, well, how do you move a point right 2? Well, the x just becomes 2 bigger. The x becomes 2 bigger, and the y's stay the same. Now I'm going to plot 2, 1, 3, 3. And those are 2 important points on this graph. The other important thing we're going to graph is the asymptote. I'll give you a quick reminder about what asymptotes are. So if you look at all these graphs, they all kind of swoop down, and they don't ever go negative. They kind of just get really close to 0. So if you zoom in real far, they're getting like super, super close to 0, but they actually never touch 0. And that's because y equals 0 is an asymptote for these graphs. Let's just look at it. So if you look at y equals 0, it's this horizontal line that the graph gets really, really close to, but it never touches. And that's what an asymptote is. It's a line your graph gets close to, but it never touches. In the case of exponentials, it's a horizontal line, and it always starts out at y equals 0. If you have a transformation up or down, it might change the asymptote. Left or right won't change that asymptote. Okay, if you have a horizontal line and you move it right or left, it's still a horizontal line. But if you move it up or down, then you have to adjust what it is. Okay, so in this case, we only moved right, so our asymptote is still going to be y equals 0. Okay? And we need to draw that on the graph. We should draw it as a dotted line. Y equals 0 is a dotted line on our graph. Finally, when we go to actually sketch the graph, we know it's going to make that rocket ship, and we know it's not going to cross that pink line. It's going to kind of go up like that. Cool. It's important that we make those 2 points that we know, that we figured out, really clear to make sure our graph looks good. And that's what y equals 3 to the x minus 2 looks like. Let's talk domain and range. Remember, domain and range is our x values. It's left and right. How far left does this graph go? Negative infinity. How far right? Infinity. It keeps going off and off and off and off. That's always going to be the case for every exponential. The range is defined by the asymptote. So once you figure out the asymptotes y equals 0, your range is just going to be 0, infinity. It goes from the asymptote up. Remember, range is your y value, so the lowest y value is the asymptote, and the highest y value is infinity. We don't actually touch the asymptote, so we're always going to put a parenthesis there. Okay? That's it. Okay? This exponential stuff's not going to be too bad. Let's do another one together. I'm going to do it a little quicker here. I'm thinking about 2 to the x minus 1. I'm going to think about just regular old 2 to the x first, and I'm going to figure out a couple of points on that. I know 0, 1 is on it, and I know 1, 2. 2 to the first is 2. That minus 1 on the inside, excuse me, on the outside, it's going to move the graph down 1 to give me this. And so my x's are going to stay the same, but my y's are going to decrease by 1. I'm going to plot those points. My asymptote is normally at y equals 0, but now it's shifted, the whole graph shifted down 1, so the asymptote is going to be at y equals negative 1. Those up and down shifts change the asymptote, because it's a horizontal line, moving it up and down is going to change it. And that's important to figure out right at the beginning so that we can sketch it in there and get an accurate shape for our graph. That's what it looks like. Domain is always negative infinity to infinity. We don't even have to think about it. And the range is just from the asymptote upward. Parenthesis there. Okay. It's not too big. Go ahead, pause, give this one a try. Okay. That's what you should have gotten for this one here. So here's my table for my couple of points for 3 to the x. It was moved up 1. So I add 1 to the y's to get these 2 points. Don't forget, the only tricky thing is that up 1 is going to change your asymptote. Okay, so when you move up 1, your asymptote, instead of being y equals 0, is going to be y equals 1. So it's going to be right here. So then the range is 1 to infinity, and domain is still negative infinity to infinity. Cool? I don't think this is too bad. Go ahead and give number 4 a try. Pause, give it a try, and then we'll go over it. All right, check your answers here real quick. Make sure you got all the features right. You also got those 2 points, 0, 0, and 1, 3 are kind of those 2 key points I'd like you guys to have on there. All right, let's do number 5 and 6 together here, because you'll notice what changes here is our base. Our base is now 0.5. It's 1/2. Okay, so instead of being exponential growth and shooting off like that, it's going to come down like this. Just got to make sure we're aware of that so we don't sketch the wrong shape of graph. Besides that, though, this is not too bad. Really, nothing is changing. except for the general shape. I'm going to think about, excuse me, there's no transformations here, so I'm just going to make a table for 0.5 to the x. I'm going to still have 0, 1, and I'm still going to have 1, comma, base, whatever the number is that I'm putting to the power. That's because anything to the first power is just itself. So what's 0.5 to the first power? 0.5. So here are my 2 points, 0, 1. Oops. And 1, comma, 0.5. Asymptote is still y equals 0. There's no transformation, so that didn't change. I just gotta be careful to remember that when I'm swooping down through those points, instead of swooping up, it's kind of gonna look something like that. Domain is still negative infinity to infinity, and range is still whatever the asymptote is to infinity. Be careful here, the range isn't like negative infinity or something like, it's still, the lowest y value is still 0 and the highest is still infinity. Even though it's swooping down, the range is just capturing what y values are, not like the order that you get. So it's still just 0, infinity. All right, last one, I want you to pause and give this one a try here. Be careful, you got a transformation going on here now. Okay, so here is our table for 0.5 to the x. That plus 2 was in the exponent, and that counts as on the inside. So it was moved left 2. Here are my new points. Plotted them there. There was no up or down movement, so my asymptote was still y equals 0. Sketch the graph, it swoops down. Range is still asymptote to infinity, and domain, even for the ones with the decimal or the fraction basis, the domain's still always going to be negative infinity to infinity. Okay, so we'll practice this together some, but I hope it's not too bad. A lot of ideas we've talked about before, like domain and range and stuff. Thanks for watching, guys.